there are very few things today where semantics is used in isolation. There are a whole bunch of semantic technologies or semantic web technologies. You'll see some list here, right? But far more than any one of these technologies will be the use of principles of semantic computation or semantic web technology in conjunction with other things. And those other things are very often machine learning or NLP or data mining, things that also largely make up so-called data science kind of work. So there is a huge value in learning how you deal with the data and understanding where machine learning helps, understanding where data mining algorithm helps, understanding where NLP techniques help, understanding and how any one of these can be improved using semantics. That has far bigger scope of use and application than so-called semantic web technology in isolation. I also teach another course, and some of you may have a chance to take that course sometime later on if you're going to be here next year, and that's called Web 3.0 course. That's also closely related course. The difference there is that in the Web 3.0 course we are going to explicitly work with social data, sensor data, genomic data, variety of different data of different modality. Here we are going to more remain core or closer to core of semantic web and semantic techniques. And yeah, your project may involve other kind of data, but the focus will be a little less on dealing with different kinds of data or different modality data, which is what we'll do again should you take that kind of course. For many, just taking this course is enough and you don't have to take that course, or it all depends, right? And if you're doing PhD with me, then I'll say take that course, we'll do the project anyway. Okay. Now, what we are going to do is to get a very broad introduction to semantic web. And but in the next class, you're going to come prepared with a lot of reading. So always come back to this page, and I may also post, but you can see here in the class, second class, we're going to do this 15-year overview, and there is this blog item that I posted. And this is what you're going to have read very closely in detail before you come to the next class. So it will be a wrong thing to come to this class without being prepared, because you really not get much out of it. And again, this class is not for you to come here, listen and get tested. It is for you to really learn. Now, a caution. So when you go through this, when I'm saying go through this is not just going through this, what you see here, which is not very short but not very long. It's just like, I don't know, 5 pages worth or less. But that's not what I want. I want you to look at every link. Then it will be up to you after, so you click on this link and you read this, and if you figure out that I think you got an idea, you don't need to read every word, it's up to you. In early phases, I would suggest that you do read until you feel very comfortable. So you can see here, there are so many links here, so many videos here, right? And so many papers here, and there is this patent. I want you to read the patent. Actual reading of the patent is only like 8-10 pages worth of thing. But I will say that I would require each PhD students to read the patent, and I will make for master students that to be optional. Why? Because every year at least 2 of my students file for patents when they are doing internship. And there is 80% or higher chances that if you do 3 internships, as all my PhD students do, or practically all of them do, that you will have filed for at least 1 or 2 patents before you graduate. You can go through the web pages or resume of any of our students who have graduated. You will find that they all have filed for patent. This is a great training for you to have, right? So when you will get hired as an intern, your mentors expect that you actually learn, that you actually contribute to writing a patent. Companies like IBM Research would like to file, or Fujitsu Research or Samsung Research. They would very much be interested in filing a patent before you publish what you did during internship. Okay, so learning how to write patent, what is patentable, how people express ideas in a patent is a very good skill to have, very good knowledge and understanding to have. That way, when you start your internship, you're kind of clear. You kind of can think in parallel. Am I working on something? Should I talk to my mentor? Yeah, I got something. Do you think the company would want to file a patent? So this is something that is very important. There are other things that I want you to read the patent for, because I'm very proud of this. The reason I'm very proud of it is that this patent was filed in year 2000, August 2000. It was May only in 2000 when this very well-known paper, which I had not read by the time the patent was filed, came out in the Scientific American paper on semantic web, which I also has a link to here in this blog. And that it is important as part of this course for you to understand what is called semantic web, the whole range of semantic web solutions. I was always on one end of that, which is what is more practical form of semantic web, and which is what has succeeded in my view. And I've been totally vindicated, I feel, and this blog is about that, saying 13 years after this patent was filed and awarded, 12 years after it was awarded, Google came out with Google search. What is fundamental idea about Google search was already done at the time of filing this patent. And actually in year 2000, I gave a keynote because I had founded a company in 1999 that was Semantic Web Company. So that came out before even the Scientific American article, and that article has put forward a vision of semantic web that never came through, but this one did. So that is well known, and yet some of you are going to be student of an advisor who were on this point, and this side of it which came through. To Saida, I'm going to give you a very interesting thing to discuss. Our well-known colleagues Handler and Natasha just published a revisiting of semantic web this month. Have you seen that? Their paper in Journal of Web Semantics on revisiting semantic web. So we'll have discussed this, and we will ask the class to read this new paper, and you should do also, and then I'll request you to lead discussion and present your view and everybody's view into this old pattern thing, the Scientific American article in 2000, and what they are calling new, and see how the thing all fit together, right? In the process, since you are also, she is very much into a very important part of semantic web called linked data thing, so she has been quite involved with that. And if you don't know, by the way, Saida is a postdoctoral fellow, and that's an important component of semantic web, and so she's familiar with that too. So I think it's very important for us to understand in the whole scheme of semantic web where these things are. So you get an idea here There is a very interesting interview that was published in year 2000, in March 2000. And so I said this is a verbatim text from this 2000, and it is worth reading that. And then I later on in this blog go on to discuss the semantic search and other techniques that we developed, and then what I saw initial version of Google semantic search did. Okay, so and then you can see there's so many other pieces of things to look at, right? So this will easily take you 6 to 8 hours of preparation, so please do find time. And it's possible that we may run over the schedule here, but then in the third class, we'll call our recently graduated Dr. Sujan Pereira to essentially demonstrate us, to discuss the role of semantics in NER, in information extraction. So here again there is a big body of work in information retrieval, natural language processing, machine learning for entity identification, for entity linking, for disambiguation. So there are a series of these important things that are done as part of this. This formulates this is a very core part of semantic web, and also it is a very core part of what machine learning is often used for, right? And hence, or what often lexical text analytics, they are all based on a lot of higher end text analytics or NLP require that you identify an entity, right? That what are you talking about, regardless of textual differences. So that is a very fundamental thing in many disciplines, subdisciplinary computer science, and understanding what semantics does for that is very important. So that's what we will talk about in this class, and we'll see, it may run over, but these are very sort of fundamental pieces of semantics. Once we have done that, we are going to go into quick review of standard semantic web technologies and standards. And it is possible to devote the entire class to that, these things, but we won't want to. We would not like to do that. That means that there will be a lot of work if you are not aware of it. A few of you would be aware of these things, others will have to very quickly pick this up. We have a lot of material for you, because on all of these things we have captured videos before. There are video tutorials by other very well known, and people have done a lot of good effective job of presenting tutorials on that, and you'll find all of those things showing up in this thing here when as we schedule that particular topic. So you can just click on all of those things and review all of them. What we will try to do is that we would like to see that you gotten practical knowledge out of it rather than just listen to the lectures. So the idea is that, let's say this RDF kind of stuff, I would want you to read and watch videos and go through tutorials before coming to the class. In the class, some of our experts in this area, like say Vin is an expert in RDF data model. So we'll give you a little assignment or another exercise. So we have preparation before the class, and in this case there will be exercise that you will do in the class, and you'll ask questions, and Vin or Saida will be available to answer your questions.
Actually, the question, the primary document that I would suggest to read is that W3C recommendations.
We'll put those as one of the things also.
So for RDF, Sparkle, all of these technology, they have actually recommendation page that all of these standards described properly with some examples.
For some, reading recommendations from the beginning may not be that easy and understand. So they may also want to watch a video tutorial.
Yeah.
But it is very important to be able to read those specs, and because as Saida pointed out, that's what you'll have to do in real world. So today we are going to learn about these things, these technologies and these concepts. But tomorrow you will have to learn about something new. That when you're working 5 years from now or 3 years from now, and something new is there, how do you go on the web, find what is the most relevant material and learn from that kind of thing. And this kind of material that that she's going to ask you to look at, or I will put the links to that in W3C material, World Wide Web Consortium material on this. That's authoritative, and either you will take that kind of material or you will take some primer book on that topic and learn those things. So it's something that you've got to get used to in case you're not already doing it. Some of you may already done that, others will have to get used to those kind of stuff. Okay? Alright. So with that, let's go on to I'll give you my introduction to this topic. Let's see, control minus. Okay. Maybe I'll just use this as well. All right. So let's look at my introduction to Semantic Web. What are the most recent software internet success stories? As you saw, this presentation was prepared last year. We'll see the other thing, but I should not have should answer. But anyway, here they are, right? Some of the things that I think have been talked about quite a bit. There are others. There are other major progress in robotics, for example, autonomous systems, self-driving cars. These are some very important things. But in one other areas, particularly web-related areas and search and these kind of things, these are some of the very, very important things. And some of these are really continuing. Apple is continuing to develop next generation of conversation engine. So now, and I should update this, but basically now the next generation to these are these so-called bots, and then there will be personalized bots. So you'll be asking questions and they'll answer you personalized answers, right? So Siri, just want to point out a couple of interesting things. The Siri itself started at SRI, so it's Stanford Research. It's nothing to do with Stanford University, but there is a research outfit called SRI, pretty close to Stanford, and much of their work is government funded, typically Department of Defense, DARPA funded, that kind of thing. And they had this project for kind of local search. So they developed sort of an ontology, like set of facts, a knowledge base of local area, and then they started to essentially develop a search for a restaurant nearby, movie theater nearby, things of that nature. One important piece that then came into this general type of technology is being able to speak to the tool rather than type it. So there has been massive, significant progress in speech recognition, and combining the speech recognition and question answering system. So this is a very good example of question answering system. Apple Siri. Again, so it's an area that Saida is working. IBM's Watson, their major showcase was that the machine, or Watson IBM, competed with the two winners of Jeopardy, again question answering, and won significantly, right? I mean, by far. Then the Watson has become, by the way, just kind of a brand name. So IBM now has Watson Division and Watson Health Subdivision. Some of my very successful students are working there. Kartik Ramakrishnan, Meena Nagarajan, and until now Pablo was working there. Pablo just last week joined a startup founded by Christopher Ray, who was at Stanford, earlier CMU, a professor there. And then in 2013 came semantic search, Google. And what is, the question here is that all of you, I'm sure, have heard about significant success of machine learning. The important thing to recognize here is that in this particular case, all of them use machine learning, but semantics, particularly in the form of ontologies and knowledge, played a very important role. Okay. So that tells you that the kind of things that we're going to talk about in this class are very important. Interesting thing here is that there is no Watson project being done that does not involve use of background knowledge or domain knowledge or ontology that I know of. Right? You talk to Meena, and they're using same general philosophical underpinning that they learned in this course and in this, in this lab. They all are developing ontologies first, and they are all applying ontologies in their data mining and machine learning algorithms. You should look at the 2 papers that Meena wrote for KDD last 2 years. Right. So now, even though machine learning, and so because AI has been a very successful thing, and semantic web can be considered to be one of the topics in AI, but a much bigger topic in AI is that of machine learning. There have been a number of, when you see commercial activities, you become, you can start to believe that there is a real, something, that there's much to come. And so, for example, Microsoft purchased PowerSet in 2008. I think that was for $100 million or $200 million. Apple purchased Siri, the number I heard was 200 million. Google bought MetaWeb, probably quite cheaply, but MetaWeb is the one that made Freebase, which was manually created knowledge base of 5 million nodes in some relationships. And then Facebook has Open Graph, Twitter has its own annotation work going on, and so on and so forth. So you can see that somewhere in 6-7 years ago, people started to see that there was a technical, that semantics would start playing an important role. The first use of what semantic web was in 1999. And if you look at semantic web as semantics plus web, then the idea existed long time before that. So I would like my students to look up the paper that we had written in CIKM in 1994, and it was a Rutgers report in 1993. It was with my very first PhD student, his name is Vipul Kashyap, where we talked about using multiple ontologies to formulate a question and then get the answer from a data source. Right? So there were federated ontologies that were done there. There were other contemporary projects also, particularly at ISI, they also looked at ontology in generally that time frame. So the idea of use of ontologies and knowledge bases for improving search, for understanding content, for tagging the content, or for integrating data from multiple web-based sources or databases dates back to 1993 at the least. At least my work was, with Vipul was in 1993. I'm not, totally sure. What ontology itself, which has played a very important role, whether it's a formal ontology or less formal ontologies, whether it's knowledge graph, that is how it is known these days. That itself, the word ontology is very, very old. You can talk about ontology in philosophy and that kind of thing. But in the context of information system, the ontology came out, word became noticed when Tom Gruber used it. Tom Gruber comes from Stanford's Knowledge Systems Repository, KSR lab, and there's some very well-known professors in that area. And then his thesis talked about ontology, and we'll see the definition of ontology shortly. Right? Today, more people would use the word knowledge graph. Let me just mention that in passing. So we'll look at some distinction between those things. Now, this knowledge, the ontology, what happened here is, so what happens here is that in all of these projects, ontologies play some role. Whether the ontology was created, whether the ontology is used to enhance the understanding of content of data, okay, or disambiguation as an example, or whether ontology or knowledge graph was used to connect the data, right, or interoperate across the data. But those vary. Okay. My own use of ontology was 1992. That means that the year in which Gruber's thesis was, I'm guessing, is 1991. Okay. So I had a paper and a keynote called So Far Yet So Near. So far schematically, yet so near semantically. That was in 1992. The data semantics working conference in Lone, Australia, and there I used the word ontology in the context of asking the fundamental question: how are two objects related? How similar are two objects? How different are two objects in terms of the information they capture or convey or represent? And that's a fundamental question you have to ask in information system. And then we had a paper on multi-ontology query processing, 1996. And we did conjecture in one paragraph in that Rutgers report that the content can be on the web or it can be a database. But the credit of coming up with this, and we use the word semantic information brokering for what we were doing, whether information was a database or a web page. But often words are very powerful. So credit goes to Tim Berners-Lee. He has marvelous book, and I had copies. I bought several copies of the book. I give it to my students, but they never come back. The name of the book is Weaving the Web. Right? And so as a kind of father of the web, he wrote that book. And in chapter 12 and 13, he conjectured that web data should have metadata, and he used the word semantics to describe putting the metadata on the web-based content, and use the word semantic web in that.
Was it 2006? Is that?
1999 is the Weaving the Web book. Right? So all the things are before 2000. So that book came out in 1999. it so happens that I founded my own company in Semantic Web company in also 1999. Initially, I would have used the word semantic information brokering, but I was smart enough to recognize that Tim's use of word semantic web is far more powerful and than my use, our use of word semantic information brokering. So there's another word also that was popular that was coined by Geo Witherhold at Stanford, and he used the word information brokering. No, sorry, information mediation. So brokering is the word that I prefer and with Vipul, my PhD student, and mediation is what Geo had, and then this semantic web came, and then later on, and as you saw, I mentioned, I recognized the importance of ontology way back in '92. Very soon after, immediately after, I think Gruber started his, talked about ontology in his thesis. In fact, I'm not sure. Somebody needs to check, but I think 1991 maybe his kind of report, and 93 maybe formal publication date for the dissertation. I'm not sure. Nevertheless, the credit does go to him to bring the word ontology in the information system in the literature, and it's been used since then. I've been very lucky that many of my early years of research happened with major trends. So this is the background of semantics, right? It goes back to the very first paper published with the semantics was '92 paper. So it was pretty early in those days compared to the time when the semantic web became popular. The other thing was web itself. Remember, the World Wide Web came up, was mentioned in 1989. It was late 1990 when the first server was actually implemented. 1990, late. Okay, and it was not really useful, or not many people noticed it. There was a very small thing. Of course, credit goes to the fact that Tim Berners-Lee, architected that and recognized the power of taking a subset of SGML to define HTML. The concept of hyperlinking existed well before Tim's use of that, but HTTP was also a brilliant idea of a server. Any server can return the document in HTML, and this client server, you have to have separate software for client and server, and that problem, rigidity was broken by use of the web technology. But the real, potential of web was only started to notice once the Mozilla browser came out. And actually, World Wide Web itself came, the term was coined because the first browser was called www. Okay? And then 2000, in sometime, certainly, I think 1991-ish, or World Wide Web, Mozilla was 1993. I realized the power of that. Thankfully, I was exposed to these tools that were, I won't talk about this because it will take too much time. But there is a lecture and video that if you're interested, you should watch, that I recall some of the history of the web kind of stuff also in our Web Information System class. But 1993 itself, I initiated a project. There's another colleague, who was also very much, who very much worked on this project. It became Info Harness project, where we searched for heterogeneous, meaning documents with different formats, using a web browser. So it's a search of a form, right? So what we did was to take document of different forms, different digital representation forms, different syntax, right? Formatting, and talked about associating metadata, extracting metadata from the documents, indexing that, and making them searchable from the web browser. Remember, the whole thing about metadata realization, Tim Berners-Lee brilliantly talked about in his book, but that was 1999. We are talking about 1993. And then it became commercial product from Belcore in 1995, But I could not convince Belcore because these big companies, they have MBA types, they want market study and how much business will be, and then they'll sanction your product development plan. So I couldn't convince them. So the product that we developed only served the Baby Bells, the telecommunications company that were customers of Belcore. Otherwise, it could have become a big web search engine right there itself. And there were some other engines called Excalibur, and others were developed in that time frame. 1998, I started a project funded by LG Electronics. LG is a electronic company and a TV company and all that. And so what we sold an idea to LG that we'll develop a cable set-top box based software written in Java that will index all the 3 different kinds of video. One is the description of video in electronic program guides. All the TVs, all the cables, everything, you have electronic program guide, right? What show will be there at what time. So that is description of the video. And the idea is to capture all the content from electronic program guides and then index it. And so if you search the system, you say, oh, this will, this program will be at this time. You don't have to browse through that because we'll wait for the whole thing to slide by. And then you can possibly put a link saying, okay, start that program when it is going to be on, even if I'm watching some of the program. Number 2 was video that will be in your custom library, because the digitization video is happening then. So there were, hardware that companies were selling. They still sell today, but now not many people buy. Where analog tapes will be converted into digital tapes, and it will be going on your hard drive. And we wanted to index that so you can search that content. And the third content was content on the web. I felt that content, video and audio and video content on the web will grow fast because there was a lot of discussion in the technology press and in media that broadband is coming. Remember, we are talking about the days where modem was 56 kbps was a big bandwidth. Okay, so but I think we recognize very early that this digital media would be coming. So we developed indexing of video, audio on the web. We developed this software and did a demo. And our agreement with LG was that if they want, they can license it and from the university, because I did a project in university, and they can make a product. So they have so-called first right to refuse license, or if they don't, then I have right to. University has the right to do what they want. Well, they didn't exercise their right. I mentioned to them, so I took the right from the university and founded the company Tali. Tali means, in Hindi language is applause. An applause of coming together of broadband and digital media. That was the idea. And in year 2000 itself, we developed the first web search engine for audio video. And it was not only search engine, it was a semantic search engine. Because we developed ontologies of every domain. So we said we noticed that there is web, video on the web that are about TV, movie. In those days, not the entire movies were not there yet. We are talking about 1999. So we said, well, but they would put in the what you call teasers, right? So plus the music video and those things they had started to come. Okay. So we would index all of them, but we also saw videos of the sports games. Little snippets of those days. They were not more than few minutes long typically, and they used to be QSIF format, Q quarter thing. Because to save bandwidth rather than the whole screen, they will have quarter screen kind of thing. Okay. Anyway, but with the broadband coming, I said, well, there'll be a lot more there, so let's be the first one, right? And so our search engine first was called MediaAnywhere.com. And you'll read about that in that year 2000B citation that I showed you. that is citation about our first of semantic search engine. And I think the very first keynote that anybody gave was the one that I gave in year 2000 in Portugal at the first ever conference on semantic web. Not conference, workshop. It was first ever workshop. There was no conference yet. And at that time we already had a commercial product. We had, and we had 3 customers. Okay. Eventually what happened was that we could not become Google. The reason had a very different thing. Google had raised $25 million, and it took 7 years for Google to come to the IPO in 2004. 1997, 2004, and they IPO in this. But they got they had backing of a major VC called Sequoia, and I had rather modest funding. I could have taken more, but my VC said, well, we'll get money again when you want. And then the market went down, April 2000. So my company survived, but we became enterprise company serving financial services market. Okay, moving on though. So what has happened also is that there is a adoption of kind of here I talk about RDFA notation, but another thing that has become very successful now, and I'm not going to bypass some of the details here, but schema.org has become a very important showcase of success of semantic web principles, so semantic technology principles, and in a way you might call it technology. And here, quote unquote, the ontologies created by the people, the organization who manage semantic schema.org. The main person behind schema.org is Guha, right? The same Guha that he and I are the track chairs of semantics and knowledge and semantics track for the World Wide Web conference right now. So Guha is a brilliant guy because Guha also developed MCF, which essentially defined RDF. RDF became standard in 1998, very early. So the World Wide Web Consortium, but the word semantic web was not coined in 1998. Very interesting. And my first paper utilizing RDF is in 1998. So I defined, I had a student, who was it? Kshitish Shah. And he was the guy who was the developer, along with Leon Sklar, of the commercial version of the info harness for the Belcore. So he was very much interested in all these things. But also along the same time, by the way, some of you have heard me talk about Selvam, right? The guy Selvam was my master student. He did thesis. He's the guy who joined Jungli, who used semantic approach to integrate databases, was acquired by Amazon for and in fact. Interesting, in less than a year of his working, his stock options were worth 400K. Amazon, he ended up establishing Chennai, Amazon's Chennai presence. He was also the guy, director at Netflix when Netflix moved from to Amazon Web Services, and he also was the Groupon APAC chief and spent time in India. He did NGOs for social service, and now he's the head of Allen Institute for Humanitarian Initiative on the technology side. He's a technology head of that thing. So he his thesis was on when you have in HTML you have href, right? You have link. The link is a physical link. It says for these words, here's the link. It takes you document. So you don't know what that document says, and you don't know why that link is other than this just text. So I asked him to write metadata, give associate metadata to href, and we call it mref. M for metadata, metadata reference link. So a paper on that, and we demonstrate the use of metadata reference link. So when I put, let's say, here is a document, here is a text, and I put a link to a document which is another HTML document, versus I put a link to another document that's a video, not a HTML. And that video is MPEG 4, and it has metadata there, right? So what if I were to actually describe what is it that the link, right? It's a very powerful concept. I'm very sad that we never took it to its full potential. It's just I guess a timing issue and getting a student to get engaged in that. But otherwise you would have developed a relationship centric semantic web very early. This was 1997. But that importance of metadata and associating that, and so there's 1993 paper showing for digital media, and then 1998 paper where the same year where RDF became the standard, we had a description of mref in RDF and OWL. And OWL was not even standard then. Right? Anyway, so schema.org has become very, very important. And so so some of these are now described on this page: semantics with metadata and ontologies. I use that semantic information brokering and faceted search. Info analysis was basically faceted search engine. And then there's this ISI work was Sims and Ariadne. Then we had a project called Observer, and the shoe was a very well-known project by Jim Handler and his student. I think that's from 1996. mref 1996, 1998, InfoQuilt 1998. There's a lot more I won't want to discuss. And then Tim Berners-Lee used semantic web in 1998 book. I founded this company and filed that patent in 2000 that I mentioned, right? And this well-known article talked about AI-ish approach to writing intelligent agents. And then the first 5 years spent too much time in description logic AI, which has not become successful at all. But we should be knowledgeable about it. And then Tim started to focus on data web, and that, again, he kind of finished things that led to LOD, linked open data, and defined first set of principles for that. And then current, biggest use of, semantics in such context, and that's that one that we're going to talk about next class. So semantic web, in my view, my perspective is very, you need to describe complex idea but in very simple way. Anything that is important really should have simple explanation. So I have a simple explanation for, 3-point explanation for semantic web. First is some common understanding documented in the form of what you might call an ontology, and if there optionally, so that may be just as at a schema level, or it may be instance level. Your description or description and description base, schema or knowledge base, right? So documenting, representing the agreement you have in common interpretation of terms, nomenclature, and having the facts that are already known to the world about that particular area, you capture that as an ontology. Of course, there are other things. I'm going to upper ontology and domain ontology and other things of that nature. And then, if it is represented in a machine processable language, with the formality has more, the more importance of formality in representation has more to do with the uniform interpretation by different pieces of code. If you did not make it formal, different people may have different interpretation. So prior to this so-called semantic approaches, there used to be, and there still is somewhat, an area called EDI, electronic data interchange, right? And EDI was sort of a message format to say this is a property and this is what it means. But it was described always in English language or whatever language. And there was no formal representation. There was no, formal language such as an OWL or RDFS or an RDF that had more uniform representation. So different people could interpret this textual description differently. And hence, there were a lot of still misunderstanding, mismatch, and lack of interoperability because of that. By the use of formal language, particularly formal knowledge representation, gives you, this uniform interpretability. That is important. The second thing is semantic annotation, what we will probably do in our class 3 or something along that line, right? So it is basically metadata. It is, it is again, in this document there are concepts that are described as in this ontology here. So Sujan will talk about name entity recognition and linking, and the distinction will again come to that, so let me not go into that right now. But this thing can be manual, semi-automatic or automatic. Okay. So for example, to understand that this is a human name of a person, you can use very simple heuristic that, if the name is spelled, first name and last name, and so the first letters of the words would be capitalized, and these words are one after another. Or the syntax could be last name comma first name, and then you can describe that syntax using linguistic rule, and you can say, oh, that's the name of a person. Similarly, for example, when I did this company Tali, in the same time frame, IBM had a a project called Web Fountain, and very I think some of my students worked on the Web Fountain project also, and then we also had what you call an agreement to work together with Web Fountain. So for example, in Web Fountain they would write minors. The minors could be sort of syntactic rule based minors. So they will write rules for to recognize address, location address, right, from the text. So there will be rules of there is a first street, street 1, street 2, city, that kind of stuff, right? By the way, address recognition is not easy, but again, the idea is that you try to do as well as you can. Alright, so that is the second thing. Point is that there's another thing, and Tim Berners-Lee once describes semantic web in a very simple way. He says it's about labeling the content or data. Right? You have data and you're labeling it. This is what it is. This is name of a person. This is name of a company. Of course, that's rather simplistic in that you still have to then properly characterize what is the name of a company, when it is name of a company and not name of something else. Right? So for that you need this so-called ontological representation, right, or modeling. But the fundamental issue is that labeling. So semantic annotation is very, very fundamental to semantic web. And then there's another thing that I'm very fond of talking about is this going from data and understanding the syntactic metadata, structural metadata, and semantic metadata. So here is an example, and you remember I've shown this pyramid in different forms. Another example is at 150, then 150 mmHg, which is a systolic blood pressure, and then because it is higher than 140, it is excessive blood, high blood pressure, or rather no, it is elevated blood pressure technically, and then it could be either because of hypothyroidism or high blood pressure. And then for each of them the treatment is different. But going from that 150 which a machine gives you, to what is the impact of that in your human health. That is a very important thing. So another thing that is very popular in information science systems literature is DIKW triangle or pyramid. So D is data, I is information, K is knowledge, W is wisdom or something that you can act upon, right? Understanding, insights, blah blah blah. But this is another thing that you can understand what each of them mean. Suppose I say here's a document and the document has X number of characters. That doesn't say anything about what document says. It simply gives a syntactic thing, right? But then suppose I say structure, there is a structure and there is a style sheet and there is a tree structure of XML. Then I am giving you syntactic thing. But then I describe what is in that document and this discusses these concepts of relevance to application. Then I am talking about semantic metadata. I am bounding the interpretation of this metadata using this ontology. Okay. Higher you go, there is more meaning to the words. Okay, so that is the one that I was talking about, is right here. You have 150, it's a raw data in text, systolic blood pressure of 150, and 150 has no meaning. But this is why we can call this information or annotated data. Because it's a notation, right? This is 150 mmHg unit, it's a blood pressure, that's a notation. Then you say, it's interpreted, it is elevated blood pressure. It's higher than NIH guideline, NHLBI, National NIH Division on Blood Related Disease, blood and heart, health issues, it's called NHLBI. And they have a recommendation, they say systolic blood pressure about 140 is elevated. This itself is still not sufficient for doctor to decide what medication to give you. It is high, it needs to be treated, but how? You don't know until you can figure out whether it is because of the disease of hyperthyroidism or hypertension. Based on that, then you can decide the medication. There's some more theory, IntelliGo and all that I won't talk about now. Third thing is, once you have that, let's use those metadata, let's use those annotations. And there are different forms, different reasons, different applications in which you use the application. So this of course oversimplified, but you can do search, integration, question answering, connections, path, pattern, discovery, visualization, hypothesis validation, all this kind of stuff that you can do, right? Because you can do that much more meaningfully because now you know what that data thing means, right? Ooh, time is passing fast. And there is this so-called semantic web stack that World Wide Web Consortium has defined, and the ones in the red are the semantic web technologies for the standards rather. Okay, and we will talk about these as we go along somewhat. And then I have a little bit of introduction to RDF and all that. That will wait. You guys can go through this to get a very quick view of it. Let me show you this one diagram. So in terms of representation of knowledge and ontologies, we have a wide variety of choices. It can be very simple representation like taxonomy, all the way to highly expressive ontologies. And here you can see this catalog ID, database schema, WordNet, UMLS, then object-oriented form with the hierarchy, ISA relationship, RDF, RDFS, more of formality, then constraint representation, OWL, and even more formal thing, there's SUO and other things of that nature, and different representation forms. These are the example ontologies of using at that the different place. So Go is just a nomenclature. This is gene ontology. These, by the way, are all developed by. So Shweta was developed by my team. Glyco was developed by my team. Pharma, I don't remember whether we developed or not. And there are some other people developing other ontologies. Over the period of time, we have developed many ontologies, tens of ontologies. Some of them are public, some of them are commercial, some of them are we use today in our research. So there's a lot of work in that area that goes on. Owl and all that will come to that. Sparkle will come to that. Ontologies can be. There are more than 500 ontologies in biomedical domain at BioPortal. NCBO BioPortal. They used to be one of our partners in one of the projects that I had from NIH. They can be very simple ontology. This is an ontology. This is actually a subset of an ontology, just showing easy relationship that was used in a system that we deployed in 2006 in Semantic web enabled electronic medical records. I think that was the first system that did that, and we had 3 ontologies. This is one of the ontologies. So this was something that was actually put in practice in that time frame, a decade ago. To very complex ontology. This is describing some biological pathway and chemical reaction involving enzymes. There's some enzyme called GNT1, GNT5, you see, N-glycan, complex carbohydrate, things that in chemical reaction is described in this particular ontology, in our glyco work. And then there is this extraction of, you can give me any kind of content, media, and I write some extractor and I get the metadata. So here is this content. This is a web page or a document, and this is the example of annotation that Dow Jones Industrial Average is a financial index. Hewlett Packard is a company. The stock symbol of the company is that. Of course, that this has changed. That PeopleSoft is a company that competes with or is later on acquired by Oracle. So this kind of stuff. This is a text and that's annotation. Okay? This is actually a picture that I think I created in 2002. This is from our system. Tali became Vocate, that became Semantics. That's Semantics time frame, I think, or Vocate time frame. And this is that pattern thing that we will discuss a bit later tomorrow or in the next class. There are many applications. This is the interface of our Media Anywhere software, which was a search engine. So you had these forms like that. This is a faceted search, and you get results. Intertime. By the way, so this concept, remember I had asked you to explore the Google's information box. So this is the version of our information box, which had multiple parts of it, and there's a, this is equivalent of having a Wikipedia page. This is all integrated view. This is, if there's media, it will take you there. And then we also had merchandise, so you can take directly to a page on Amazon, where you can actually have the things sold. So, because if you see my patent application had interactive marketing or interactive advertisement as a part of a user semantic web application. The same thing was done in a browsing form, and it's a very, very interesting thing. So, in this case, let me see. This should be built. Okay. This is slide share, so it's not building. So I should have used the original file. But here is the interesting thing. What happens here is that when I type in a name of a person, the system automatically sees. So suppose what is the name of this person? Phil. Huh? No, so suppose you type in a name person with the same last name, he can be also with a different first name, he can be a baseball player or an actor, right? So you type in the name of the person, the system looks up all your ontologies and see whether any one of, whether that is this particular person is described or company is described. So the system automatically understands that, if it's an entity, it understands entity, not that they are keywords. This was 2001. Google did not do this. Bing did not do that. Excite did not do that. Altavista did not do that. Nobody we are the first one to understand that what you're typing is an entity. Okay? And it also understood the entity of this type. So if it was there was a guy with the same one last name, he would be, suppose you type in Tiger Woods, it only knows that it's a golf, and then it will give you here the directory of the golf and says which are the tournaments that he plays in, which are the what are his competitors, which are the places where his golf courses he has played in. But if that person is an actor, it will give you different things from the relevant ontology schema. And if it is movie, it will give you different thing. Right? So disambiguation, entity recognition, relationship exploitation, those are all part of this thing. Right?
You should have promoted these things.
I did. Oh, here it is. Yes. So dual. So dual, if you type in and David Dual, it understands it is top level sports golf. But if I type in Robert Dual, it will show movie stuff, and all the things come up is movie. They will come as movie. Right? And then these related strikes are also going to come up in that particular way. They are contextually relevant. By the way, brilliant thesis that Guha wrote was on context. Guha's thesis was on context. So, looking for David Dual as player in golf, right? Understanding what this entity is and is about. If you type in Madonna, it will say which Madonna you want. Madonna as an actor, because Madonna has played in a movie called Evita. Madonna as in a performer and musician, or Madonna as in religious artifact, or Madonna as in religious person that is not the current Madonna. Right? So he'll ask you that. So I'll lead you to those. Okay, now we should end up. See, this is Robert Dual, right? So you can see Dual, and it says genre of movie, credits, location, other people, cast members that he has played with, and all that, and such. Okay, so let us end here.